in these columns, we're assuming that certain key variables, namely the natural rate of interest, the expected rate of inflation, and the inflation target, are all constant. And also we're assuming that the expected rate of inflation and the inflation target are aligned, which means full credibility of the central bank. And here we have different values of the output gap. And here we have a high value, output gap is 3%, so this is an economic upturn. And here we have a downturn, and actually this is a very severe downturn of minus 8% output gap. And we're also ignoring for the time being any shocks to the short run aggregate supply curve. Why? Because we're setting PBS, the shock term for the short run aggregate supply curve, to 0. So if you remember, now all we need to do is calculate the inflation rate according to the Phillips curve. So what's the inflation rate? It's just the expected inflation rate plus 1 over the short run aggregate supply curve times the gap minus PBS, which is always 0. So you can see that the higher the output gap according to the Phillips curve, the higher the inflation rate. And as the output gap falls, the lower is the inflation rate. Now let's look over here and for this red set of numbers. This red set of numbers, this is the nominal Taylor rule. So we can see that when the output gap is high and also the inflation rate is high, the nominal rate of interest is also high. And then in order to get the real interest rate, all we need to do is subtract off the inflation rate from this nominal rate of interest, and we'll get a real rate of interest. Now, we'll notice that as the output gap falls and the inflation rate falls, the nominal interest rate, according to the Taylor rule, also rises. But if you look here, if we were to calculate out this level here, we would get a negative number. But we know that the central bank faces a 0 interest rate lower bound. It can't bring interest rates any lower than 0. So below this point, everything is 0, 0, 0, 0, 0, and 0. Okay, so now we're going to calculate real interest rates, and once again, the real interest rate is simply, this, as you remember, this is an approximation. It's simply the nominal interest rate minus the inflation rate. So you'll notice here that where the 0 lower bound does not constrain, as the gap gets lower, the real interest rate gets lower and lower and lower and lower. But guess what? Now we're stuck at 0, but at the same time, as the gap gets lower and lower, as we get deeper into this highly recessionary territory, that means that the inflation rate is going down and down and down. That means that the real interest rate that people are paying on their debt actually goes up. So you can see that. So let's take a look at these two curves. Okay, this curve here, this is the curve for the nominal interest rate, and you can see that while that here we're in territory where the 0 lower bound does not constrain, and you can see here we've met 0 lower bound territory. By contrast, if we look at this blue line here, this blue line is our schedule, and I forgot to mention that the output gap is on the horizontal axis and that the interest rate in percent is on the vertical axis. So we can see now that here we have the real interest rate, and again, while the 0 lower bound does not constrain, we have a positive relationship between the output gap and the real interest rate, and that's what we learned before. But guess what? When we get here into 0 lower bound territory, since the nominal interest rate can't go any lower, when the inflation rate rises, the real interest rate rises, That's why we get this perverse downward sloping curve for the real interest rate. So as usual, this spreadsheet is available to you. For those of you who are more mathematically or algebraically inclined, you might want to know what the equation is for the real Taylor rule. In both cases, it turns out that we have a section in the book, Where Did We Get Those Numbers?, that shows us how to get what we might call a rain or shine equation for the real Taylor curve. It's an equation that includes the slope of the line if the zero lower bound does not constrain, but also the slope of the line if the zero lower bound does constrain.